we've arrived. The much-anticipated final window that people have been eagerly awaiting for months is finally here. It's taking place today, December 19th. 3D Atlas is at its nearest point to Earth. This is the moment where the geometry is most pristine, the tracking is most precise, and the world's instruments have the greatest opportunity to extract genuine insights from an object that originates from outside our solar system. Over the past several months, we have observed this object glide silently across the sky, like a whispered secret always present, always in motion, yet always sufficiently distant for debates about it to persist. However, a closest approach changes everything. It condenses uncertainty and compels us to confront the question directly. What exactly are we witnessing? At this moment, 3D Atlas remains extraordinarily far away, especially considering human scale. We're not discussing anything that's close to Earth in conventional terms. But in the realm of astronomy, this represents the closest configuration we will encounter during its transit. It's near enough that our most advanced instruments can do more than detect a mere point of light. They can measure the coma, monitor gas depletion, assess dust size distribution, and observe the behavior of the tail influenced by solar wind. This is why countless telescopes are focused on it simultaneously. Hundreds of ground-based instruments, space telescopes, and precious time secured across observation windows that are usually unattainable. The rationale is straightforward. Interstellar visitors are exceptionally rare, arriving on their own timelines and not at our convenience. If you miss the opportunity, there are no chances for a What's made 3D Atlas even more intriguing is its unpredictable nature. It doesn't conform to the mold of a mundane textbook object. Even those who strongly advocate for natural explanations acknowledge that it has been unusually captivating. Not because it defies the laws of physics, but because it consistently ignites the same debate: is it merely an interstellar comet with unique attributes? Or are we misinterpreting something fundamental about its identity? This ongoing discourse is precisely why today the closest approach day is significant. It's the day when the most detailed images are captured, the finest spectral data is collected, and the best time series data comes in, leading theories to either become less relevant or increasingly undeniable. If you've been following this closely since the beginning, you've likely witnessed various live streams, participated in the virtual telescope project, watched independent astronomers in real-time tracking, and kept vigil through the night, observing a faint object slowly traverse the backdrop of stars. These streams matter because they create a collective public record. When many observers capture something live, it becomes difficult for a single narrative to dominate. The sky serves as reference. Another important development during this build-up has been the emergence of independent observers as reliable sources of continuity. Many viewers have noted how major agencies often release information slowly and cautiously, sometimes with little commentary, whereas independent astronomers tend to move quicker. They share raw views, describe what they observe in straightforward terms, and keep the public engaged. A notable name in this community is Ray's astrophotography, due in part to his consistent coverage of the object night after night, and how his stream has become the first place people turn when official updates have felt sluggish. This doesn't imply that independent observers supplant scientific authority. It indicates they play a vital role in connecting the public to it. Today, that connection is crucial because it's when one can tangibly sense the reality of the event. Watching a live feed and witnessing an object moving against the stars in just minutes transforms it from a concept into something dynamic: a traveler, a tangible entity crossing our sky. Now, let's address the source of unease found within some segments of the community: the anomalies. These are the recurring behavioral patterns that people keep mentioning. First off, it's essential to remember that anomalous does not equate to artificial. Anomalous refers to something that is not yet neatly explained, or that appears unusual when compared to our expectations. Nature often produces oddities. In fact, many significant scientific breakthroughs began as anomalies, later becoming accepted norms. Once we understood the underlying mechanisms, there are certain features regarding 3D Atlas that keep coming up in discussions, which we should outline thoughtfully without exaggeration. One prominent issue is the tail geometry, particularly the features described as the anti-tail and sunward characteristics. Typically, comet tails are directed away from the sun, driven by solar wind and radiation pressure that propel dust and gas outward. Thus, when a tail appears to point toward the sun, it seems incorrect. Nevertheless, in most instances, an anti-tail results from a viewing angle affect a seen edge-on in the orbital plane, presenting an appearance of pointing sunward. The important distinction here is it appears that way. It may not violate the laws of physics. It could simply be a matter of perspective. However, this still matters because it provides insights into particle sizes and distribution. Heavier dust behaves differently from lighter dust. If 3D Atlas is producing a dust population that renders these features unusually distinct or persistent, that is valuable information. Another point of interest is the comet's chemistry. Observers have noted a greenish tint at times, often linked in comet science to carbon-rich molecules fluorescing when exposed to sunlight. If spectral analysis confirms significant carbon chemistry, it does not indicate anything otherworldly. It merely indicates that the object may contain organic precursors. It reveals the conditions in which it formed and the temperatures it experienced before arriving here. And that fact is one of the most intriguing natural explanations, because an interstellar comet serves like a message in a bottle. It holds chemical history from another disk, another star, and another formation environment. Even if it is just a naturally occurring body, it represents a sample from a place we will never visit. Some have argued that the motion and trajectory of 3D atlas have exhibited deviations that seem difficult to model. It's crucial to exercise caution here. Minor modeling discrepancies can result from non-gravitational influences like when a comet releases material, it can generate small thrust effects that slightly alter its course. Such variations may appear as course corrections if they are not accurately accounted for, or if the outgassing pattern shifts rapidly. So, if you encounter discussions online about sudden changes or unexpected deflections, the most grounded method is to view it as an issue of modeling and forces, not a definitive conclusion. However, the reason such claims gain traction is that they resonate with the emotional narrative. An arriving traveler behaving peculiarly, nearing our vicinity, people desire it to be more than just a rock, leading them to fill the gaps in understanding when straightforward explanations remain elusive. This inclination is not a flaw. Rather, it's part of being human. Another recurring theme is alignment, where particular features seem to have an unusual stability or orientation that feels statistically rare. Again, the prudent response isn't to jump to the notion of intent, but to question what physical mechanisms may be responsible for such stability. Does the nucleus possess a specific shape? Does it display jets venting in a preferred direction? Is it rotating slowly or in a manner that produces consistent out? Does the geometry of the object create the illusion of alignment from our viewpoint? It's essential to remember that even a commonplace comet can appear designed if observed under the right conditions. Then we have the claims of signals, electromagnetic emissions, patterns, strange pulses, anything that implies communication. Here, it's vital to maintain a level footing. Space is filled with noise. Instruments can capture interference, solar wind dynamics change, and background sources fluctuate. Humans have a tendency to spot patterns everywhere, especially when seeking a narrative. That said, electromagnetic measurements can indeed be useful. If an object interacts with solar wind, it could produce detectable signals. If a coma sheds material, measurable effects may occur. None of this necessitates advanced technology. It simply requires understanding plasma physics and chemistry. So how do we frame this story while ensuring it remains both honest and captivating? We do so by remaining loyal to the current moment. Today is the day when the best data arrives. It is when you don't have to rely on unresolved estimates. It's when the spectrum clarifies, when the coma's fluctuations can be monitored on an hourly basis, when tail geometry can be gauged from multiple instruments, and when images from various locations can be compared. If you're witnessing this now, you're experiencing something rare by human standards. An interstellar object, a body that originated in another stellar system, is passing close enough for humanity's instruments to analyze it in depth. That fact alone is historic. Even if every anomaly ultimately receives a natural explanation, it still represents an extraordinary scientific moment. Now, let's discuss the psychological weight of this occasion, because it is palpable. Many people are feeling awe, while at the same time, others are experiencing unease. This unease does not stem from the object itself. It is not on a collision course with Earth, nor does it pose any danger to our planet. Rather, it comes from the implications of its presence. The sense of a visitor, the reminder that our solar system is not sealed off, that the void between stars isn't empty, and that materials can arrive from outside, traverse our neighborhood, and depart again. There lies something quietly humbling in this realization, as it emphasizes scale. It serves as a reminder that our entire civilization exists as a thin veil on a single planet, surrounded by an environment so vast that even a close encounter with an interstellar object is still hundreds of millions of kilometers away. Today, I encourage you to engage with this experience in the best way possible. Observe, but refrain from rushing to conclusions. If you favor natural explanations, don't dismiss every anomaly as inconsequential. Allow the data to convey its findings. If you lean towards extraordinary explanations, refrain from asserting that each anomaly serves as proof. Once again, let the data speak for itself. The true narrative, the one worth preserving, is what endures through measurement. In the coming hours, we will witness more images, more spectral analyses, and more observational summaries. And as these materials surface, you'll notice something intriguing. Some theories will dissipate upon contact, whereas others will intensify. Not because individuals believe more fervently, but because reality has a unique way of clarifying narratives. Following today, the event will begin to recede from our immediate focus. The closest approach will come and go, the geometry will shift, the object will move farther away, And eventually, 3D Atlas will become increasingly difficult to track as the world transitions to its next story. Nonetheless, the data gathered today won't vanish. Scientists will analyze it for years to come. This object represents a tangible fragment of another system's formation history, an unfulfilled sample from a place we cannot access. It provides clues about the chemical composition of other protoplanetary disks, hinting at how prevalent certain compounds might be throughout the galaxy. And this is the aspect people often overlook when debates grow fervent. Even the mundane explanation remains astonishing. A comet from another stellar system has traversed our solar system, and we captured it with our instruments. We measured it and recorded it, adding it to the repository of human knowledge. That is no small accomplishment. Thus, as we navigate the last hours of this closest approach day, I'd like to pose a simple question to you. From where are you watching? Are you following along through live streams, telescope feeds, and updates? Are you personally observing? Did you stay up late, eagerly waiting for that faint smudge to glide past the stars? Which part of this story has captivated you the most? The tail geometry, the chemistry, the speed, or simply the fact that this object does not originate from here? Share your thoughts below. I read far more than you might think, especially on nights like this. And as soon as the clearest images and data summaries from the closest approach begin to circulate, I'll return with the next update, not to hype it up or to force an angle, but to simply present what the sky has given us. For today is the moment. Clear skies.